Hello, everyone. Today in maths, we are going to be moving on from rounding and revisiting perimeter. We began to really grow in confidence when answering questions based on perimeter. So hopefully we can build on that today. So we are going to be calculating the perimeter of regular shapes today and then rectilinear shapes tomorrow, which will break down that term as well. Just to quickly recap on our learning, 627 rounded to the nearest 100 is 600 because my 2 tens rounds down. 472 rounded to the nearest 100 is 500 because my 7 tens rounds my hundreds column up. And then 412 rounds to 400 because my 110 keeps my 400s the same. 111 is closest to 100 because it is 11 away, whereas 85 is 15 away, 120 is 20 away, 70 is 30 away, and 909 is 809 away, so definitely not that one. Have a look at the table here. I've tried to match it up as neatly as I can to keep the place value grids, but rounded to the nearest 100, 3,162, we've got 3,200, 31,628 rounds to 31,600, and 316,281 rounds to 316,300. These ones, don't be confused too much by the decimal points here, and the commas are actually there to help you. So 20,906, rounded to nearest 100 is 20,900, 2,090, because I've got 0 hundreds, 0.6, rounds to 2,100, and 209.06, rounds to 200. So pause the screen here and have a little think about these two questions. What is 741 rounded to the nearest 100? As a quick fluency, and as a problem solving, you've got rounding 84,516 to the nearest 10, 100, and 1,000. So think carefully about which digit you're going to be circling and which one you're going to be underlining in there. Also, you might want to pause it here, a quick vocab check. What do we mean by perimeter and what do we mean by area? Maybe have a chat with someone at home or write down a note for each of these terms, and then we'll break down the answers on the next slide. So the perimeter is the distance around a two-dimensional shape. And if that shape is a circle, instead of perimeter, we describe it as the circumference of a circle, okay? Whereas area, instead of around, it's what's within the shape. Okay, it's the space occupied by a 2D shape. Over the next 2 days, we're going to be recapping the perimeter of regular 2D shapes and rectilinear shapes. So we have got a series of squares and rectangles here. I've put it on a nice bit of squared paper for you so it makes it a bit easier to calculate. The main steps of regular shapes is to firstly make sure we're just counting each square as a centimetre. For example, if we look at the orange rectangle here, the perimeter of this shape is 14 centimetres. That is because I have 2 centimetres on this side, and because these are parallel, I also know that I have 2 centimetres this side. So I have 4 centimetres. The width of this rectangle is 1, 2, 3, 4, 5 centimetres. So the width of the width here, this side, is also 5 centimetres. So I have 10 centimetres, 5 and 5, plus 4 centimetres, 2 and 2. So the perimeter of this rectangle is 14 centimetres. Let's have a look at a square now. Think about what facts we know about a square. Hopefully you're starting to begin with how all of the sides are of equal length. So instead of drawing the lines around every single square here, what I've done is I've used my knowledge of the properties of squares. So I have 1, 2, 3 centimeters, and all I'm going to do is multiply that by the number of sides. So one side, 2, 3, 4. So 3 centimeters multiplied by 4 is 12 centimeters. If you're not quite confident with that yet, you can just draw your lines for every square, for every box. I did discuss earlier with perimeter how you can just calculate one side of regular shapes that are parallel, that have parallel sides. So if my width here is 1 centimeter, I know that my width here is also going to be 1 centimeter. If this length is 5 centimeters, I know that this length is also going to be 5 centimeters. So to calculate the perimeter of this rectangle, I have 1, 2 centimeters plus 5, 10 centimeters. So I have 12 centimeters. See if you can do it using this shortcut method. If you're not feeling too confident, just put a neat line through all of the squares and then count up how many lines you have, and it will help you calculate the perimeter. Here are the shapes that I want you to try and do that for. You can zoom in on your screen for each shape if you need to. You just pause it and then hit in the right top hand column on your screen. You can hit zoom in the percentage, okay? The answers are coming up on the next slide now. So our red rectangle is 26 centimeters because I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 centimeters here. So I know that this width is also 12 centimeters. 12 times 2 is 24. And then I've got 1 centimeter here and 1 centimeter here. So 24 plus 2 is 26 centimeters. Let's also pick the blue square here. 24 centimeters. So I know my properties of a square that are going to be of equal length on each side. So I'm just going to choose any side at random. I'm going to go for this length here. 1, 2, 3, 4, 5, 6. So I can do 6 multiplied by 1, 2, 3, 4. And the product of 6 and 4 is 24. Check your answers with the other ones. Unfortunately, I didn't have an orange highlighter, so we went for pink. Why not? Finally then, your next 2 tasks, hopefully you give the Challenge X a good attempt. First of all, can you draw 3 of your own squares or rectangles, maybe a combination of both, and accurately measure the perimeter of each shape? Maybe try to do one quite maybe long and thin. Maybe try to do a really large square. It's up to you. Your Challenge X, a bit trickier. Can you draw 3 different squares or rectangles, but they all have to have a perimeter of 20 centimeters. Think carefully about how the 2 widths will be the same and the 2 lengths will be the same. So it's all about doubling and halving. For example, if I have one width of 4 centimeters, my other width will be 4 centimeters. So my other width will be 4 centimeters. So that's 8 centimeters, which means for these 2 lengths, I have 12 centimeters left. So if I half that, I've got 6 centimeters and 6 centimeters. Okay, I know that's more of a verbal hint there instead of a practical one, but that's why it's the Challenge X. Hopefully, we can see some really accurate measurements of perimeter in regular shapes. Any questions, please don't hesitate to email me and I'll give you some more pointers if you need it. Good luck, have fun, bye-bye.